Okay, so properties of sinusoidal graphs. So we have our main parts of a sinusoidal graph, whether it's cosine or sine, even though in this unit we mostly stick with sine graphs. Well, we have our period. So remember, the period is the horizontal distance it takes to complete one full cycle. So a cycle is where we start, we do the pattern, and where we about to start the pattern again, that is one full cycle. So this is a full cycle, and its vertical distance is what we call the period. Okay. Then we have our principal axis. This is also sometimes called the midline or the median. And it's just the middle point between our highest and lowest point. So if we wanted to find the principal axis, we would go max plus min divided by 2. And that's going to tell us what our principal axis is. Then we have A. A is our amplitude. And the amplitude is from our principal axis, our midline, to our highest point. And it's also the same as to our lowest point. And that's because that midline is in the middle. So if I go from the middle to the highest point or the middle to the lowest point, it should be the same value. And we can find the amplitude by going max minus min divided by 2. Or it's just max minus your midline will also tell you your amplitude, or you can do midline minus your min, that'll tell you your amplitude. Or if it's literally given on the graph, you can count up from your midline to your highest point and see how many it is. Other values that we always talk about our max value, sometimes called a crest because it's kind of the top of a wave. We talk about the min value, also sometimes called the trough because it's the bottom of a wave. So we have to be able to find all of these things on a graph because it's going to tell us a lot about our equation. So if we look at our equation and we're going to kind of relate our graph to our equation, well, we can see that there's a similar letter here. I have the letter A here and the letter A here. These stand for the same thing. A in our thing equals our amplitude. We always write our amplitude as a positive number. So even if there was like -2 written here, you would say the amplitude is 2. Okay. Another one that comes right from our graph, this value here is whatever this number is. So D equals your midline. And one thing I forgot to talk about with my graphs is my domain. Domain is nice. It's x such that x belongs to all the reals. Your range is always going to fluctuate back and forth. It's going to be y such that you're going to have your min number. greater, less than or equal to y, which has to be less than or equal to whatever your max number is. All right. So we have our amplitude, we have our midline. Then we have our b value. So our b value does come from our period, but not directly. So our b value is equal to, if we're in radians, it's going to be 2 pi divided by whatever our period is. If we're in degrees, it's going to be 360 divided by whatever our period is. So our period never goes directly into our sinusoidal equation. We always have to calculate our b value using our period. And the last letter that we have here is this C. So C is what we call either a phase shift or a horizontal translation. So it moves our graph left or right. In this unit, we basically have to be able to say yes or no, it exists. So if we see a number here, we know it exists. If we're looking at our graph and our graph doesn't start from here and go up, then we know that we have a phase shift. If our graph does start from there and go up, we know that we don't have a phase shift. So if our graph looks like this, starts here, goes up, goes down, this one has no phase shift. This graph does not start here, so we know it does have a phase shift. So knowing these letters, we can find a couple of things. For example, our max value is going to be our midline plus our amplitude. Our min value is going to be our midline minus our amplitude. And that is going to help us, of course, find our range. So our range is going to be y such that, well, we would want our min. And we would want our max. All right. Sometimes we have to convert from degrees to radians and vice versa. So if I want to go from degrees to radian, well, I'm going to take my degrees. So let's say I have 175 degrees. I'm going to times it. I want to end up in radians. So radians is going to be on top. Degrees is going to be on bottom. If I want to go the other way around, I want to go to radians to degrees. So maybe I have 5 radians. So I want to end up in degrees. So I'm going to put degrees on top and radians on the bottom. And just whatever. So we would just put that into our calculator. So I would do 175 times, we can use our fraction button, which is going to be pi on 180. There you go. So this is going to be 3.05 rads. And if I go 5 times, again, we're going to get 180 on pi. So this is approximately 286.47 degrees. This you need to memorize and brain dump on your formula sheet. These things you need to memorize and brain dump on your formula sheet. Okay, So cosine and sine graphs are very similar. Like I said, in this course, we mainly deal with sine, but sometimes they'll ask an odd question about cosine. So the similarities between these two graphs, if you notice, they have the same max and min. So we have the same max of y equals 1. We have the same min as y equals -1. They both have a period of, you can see I start here, I restart my cycle at 2 pi. I start here, I restart my cycle at 2 pi. So they both have a period of 2 pi. They both have an amplitude of 1. They both have a midline of y equals 0. The difference is where we start. So the sine graph has a starting point or a y-intercept of 0, 0. So you can see sine graph starts at, or has a y-intercept starting point of 0, 0. A cosine graph is 0, 1. So that's really the only difference between the two, is where we start, where those y-intercepts are. Okay, so problem solving with sinusoidal functions. So this might mean doing a regression. We've practiced regression several times now. So it might be a regression. So again, it's still stat, edit, x into L1, y into L2. Then we're going to go stat. And if we go here, go over. And we're going to find the sine. Like I said, we just deal with sine. So there it is, C. All right. So there's a couple of different things that they can ask us with a sine reg. They might ask us about how long to complete a cycle. So this could be a question. So they want to know the period. And we would find that by going 2 pi divided by whatever b value we found in our regression. We are going to put that to calculate our period. So let's see. So I'm going to run a regression here. Remember, this information we're going to keep all the same. We can store our regression equation, alpha trace equals, and we're going to calculate this. So you can see a sinusoidal regression is of the form y equals a sine bx plus c plus d. So same as what we have over here. So all of this information still applies to the same. Okay. Another thing that they could ask, maybe this question is talking about a Ferris wheel or a water wheel or a circular shape of some side. They might ask, what is the radius The radius is always your A value. It's your amplitude. They could ask you, what is the min? Well, remember min's just over here. It's whatever you get for your D value minus your A value. Maybe they ask for the max. So D value plus A value. They could, just like our previous ones, give a specific X and ask for a specific Y value. So that's when we're going to go second trace value. They might ask you or give you a Y value and ask for a specific X. These ones you have to be careful, right? Because they might say the first time it occurs or the second time, or how long between. So here they can ask questions like this because of the repetitive nature of a sine graph. So if I go to try to graph this right now, it actually turned out pretty good. If it didn't turn out nicely like this, we'd always want to make sure that our calculator is in radians. That's a good thing to note. Problem solving, always rads. So if you have a problem solving question, you need to be in radians. So maybe my graph didn't come out nicely like this. If I go zoom, you can see there's a zoom trig. So it's actually going to mess up my graph in this case, but it will help make it if your graph is not looking properly. So I can see I need to make my Y max higher. So let's say 10, my min 0, and there's my next graph. So when we're given a Y, the reason they can ask the first time, the second time, or how long between. So maybe I want to know when my Y equals 2.6 graph. Well, look at how many times it intersects. This is why they have to specify what X value they're looking for. Are they looking for this X value here, this first one? Are they looking for the X value here, this second one? Are they looking how long it takes to get from the first one to the second one? So if I was looking for this first one here, I'd go second trace, find the intersect, and I want to move my cursor closest to that intersection. Enter, enter, enter. So for this example, I would say that X is 0.83. If I wanted to find the second one, I could go second trace, intersect. Again, I'm going to move my cursor closer to that intersection now. Enter, enter, enter. It tells me that X equals 1.722. So if I wanted to know how long between them, I just go 1.722 minus 0.83. And the time between them is 0.892. So when you're looking for the X, you have to ask yourself which X, or which intersection. All right. Biggest things for these ones is there's always going to be a cycle, always going to be a repeat, and these amplitude, midline, phase shift, period, they're always the same idea, no matter what your regression equation is. Okay, there we have it. There's your sinusoidal brain dump. Good luck with the practice questions.